All right, so here we are. So we just talked about the 1967 car track system. Again, that's up there. The car track system, I believe Wikipedia mentions it was used for a couple years, maybe 3 or maybe, I guess 5 years, like 1973. The problem was, as you can see in this picture over here, the stickers would get old and they'd get faded, and they didn't work very well. And the result, as they mentioned in Wikipedia, was that by about 1973, only about 80% of the cars that were read by this stationary scanner actually were read. They would read this, it would get confused, and then it would run through the modulo, it would run through the check digit character, and it would never work. So imagine you're standing at a checkout counter and you try to scan something, and it sort of has a damaged barcode. It just won't scan. Well, that's the same problem with a train, but you can't rescan the train once it's past you. So they actually dumped the system after about 5 years later. But I mentioned that we use barcodes, so yeah, it turns out this idea of let's get back to scanning cases or bottles of beer. We're not going to put individual stickers on it, but we're going to go ahead and put individual bars. It sort of looks like the same thing. It's not colored. It happens to be, or colorful. It happens to be black and white. This time around, we're talking about the Uniform Product Code Council. This was in 1974. Quite honestly, this was after the failure of the car track system, so they definitely wanted to get rid of that and make something new. And they invented something called the Universal Product Code, or the UPC symbol, and we still use them today. It's been so successful that we use it, 40 years later. The Universal Product Symbol. So I have it over here. This looks like a barcode or a UPC symbol. I've intentionally put it on its side so that the bottom is here on the bottom and the top is on the top, to sort of have it look like analogy to what the railroad car system was, because it really was designed after the railroad car system. So here's our Universal Product Code, and oh, by the way, it has some of the same features. Again, this is the first part down here. Again, it has a start label or a start code, which is down here. This guy happens to have a middle code in addition to an end code. So it has a start code and an end code. And again, we're just looking at it. We're not asking humans to read barcodes. That's why we have robots. But you can see right away the way it's designed. These long extra bars on the bottom or at the beginning, that's the start code. And these long extra bars at the top, that's the end code. And these long extra bars in the middle, that's the middle code. Okay, so we have start and we have stop or end, and we have middle. In between are different characters or numbers, but they call them characters. There's 6 here, and then there's 6 there. Now it turns out that they're numbered top to bottom. That's one of the things that's differences. So we have character 1, 2, 3, 4, 5, and 6 in here between the end code and the middle code, and we have characters 7, 8, 9, 10, 11, and 12 here between the middle code and the start code, which is why we call this the UPC 12, or the Universal Product Code 12 digit. And then all of these things happen to have different names. The first character down here at the very bottom is called the number system character, and this is what this is used for, is to tell the robot what type of barcode this is. What is it used for? And then we happen to have 5 more values, just like the railroad cars, that tell us who owns this product. So we had B&O Railroad before. This is called the manufacturer ID number, the middle code, and then we have 5 more values, pardon me, that are the item number, like what are we trying to measure. And then here's this check character again. And again, the goal of the check character is to, again, once the robot reads all these other bars, is to do the math, not asking humans to do it, do the math, and then figure out if the check character that's written here happens to be the check character that's calculated. Okay. Before we move on, we're now talking about 5 digits for manufacturer ID and 5 digits for the item number. So right now we have, again, 99,999 plus the zeros. That's 100,000 manufacturers and then 100,000 items. That makes sense. That's a lot of a lot of different systems. And if we go ahead and we change the number system character from 0 to 9, then we have 10 times that. It was designed with lots and lots and lots of expansion in mind, which is kind of cool. So let's take a look at this. So here is this example over here. You'll notice that in addition to having all the bars, barcodes typically, they don't have to, but they typically have the real code, the actual code, the same code that the robot reads in human readable code, just in case the barcode gets damaged or messed up, just like the railroad car. So this really does, if I stare at this, this really is like if you want to impress somebody, hey, what's the barcode say? Well, it says 0360000291452. How did you know that? Because I read the damn thing, because that's what it is. So barcodes that happen to have the human readable code next door is exactly that. So I've just written them over here. So character 12 is a 0, and then 36000 happens to be the manufacturer's code. And then there's a 29145, which is exactly what it says here, 29145. And then this last thing is the check character. So you'll notice that just by design, the system code is outside or at the very bottom of the barcode. That's the 0. And then the check character is outside. And so these guys are lumped in a pretty convenient area. So this is the manufacturer ID. Who made this product? Well, whoever owns 36,000 made this product. And which product is this? Well, 29145 is the product. Pretty simple. The check character is calculated a little bit differently, a little more involved. Again, a computer calculates this, so don't have to worry about training somebody or having somebody getting tired. But here's how it works. It's a little bit different than the other one. Than the car track, this is the honest-to-goodness way to calculate this. You can really impress your friends. Depends on how drunk you are. You can really impress your friends if you can calculate you can guess the check character by just looking at the other numbers. Because this is, of course, how the robots do it. So here's the honest-to-goodness process inside the box. Starting with character 2, which is this guy right here. Add up the values in the even positions. Okay, so looking at this. This is character position 2. So we're talking about 2, 4, 6, 8, 10, and 12. That's cool. So if I go back and do that without just reading it down, we get a 5, a 1, a 2, an 8, a 6, and a 0. And I wrote them over here because I don't want to forget. A 5, a 1, a 2, a 0, a 6, and a 0. So we're going to go ahead and add them up. So we sum them up, we get 14. That wasn't difficult. If I wasn't explaining it, I just measured up. So the computer reads these bars, notices what the character's values are, starting with character 2, and then sums them up. Fantastic. Pretty easily done. The computer can do that lickety-split. Then the next step is to take whatever value you just got and why not multiply it by 3? This is not a random number. This is the process. Add up the even positions, take the total, multiply it by 3. Check my calculator. I get 42. Fantastic. Next step, starting with the first odd, that's not the check character. Number 3, add up the odds. That's going to be character 3, character 5, character 7, character 9, and character 11. That's the positions. We need their values. So this is a 4, this is a 9, this is a 0, this is a 0, this is a 3. So 4, 9, 0, 0, 3. Add them together, you get 16. Easy. Again, I could do this once, staring at it. I'm not doing this as a career. We need a robot to read these barcodes. The next is to add the results of step 2, which was 42, plus the results of step 3, which is 16. So 42 plus 16 is 58. Okay, this is the process. It's all kind of cool. And then the last step. Okay, the check character is the smallest integer that when added to the result of step 4 is the next multiple of 10. So it turns out that the check character in a barcode or a UPC barcode is modulo 10. So we divide 58 by 10 and we get 50 or 5 times with 8 left over. And the question is, given those 8 left over, how many numbers would you have to add to get to the next value of 10? Well, the 8 left over plus 2 gets us to 60, which is the next multiple of 10. So the check character is assigned a value of 2. So over here, that's what I said before, I said this value was 03600029145. The reason why it's 2, we just, wait for it, checked it. That's the check character. If you read all these other values, then the check character happens to be 2. The way this is done, and it's done completely mathematically, if you were to randomly change the value of any one of these characters and then put it through this system again, there is a 0% chance that you would get a 2. It's kind of cool. It's 100%. If you were to randomly swap 2 of these numbers, then it's a 90% chance that you won't get this number back. And then eventually, if you start losing a whole bunch of them, or cut this with a box cutter, or completely obliterate it, then the whole thing falls apart. But it's a really ingenious system. We add up the evens, multiply it by 3, add up the odds, add those two numbers together, and then find out how many more you need to get to the next power of 10. And that's this value here. And of course, that's where we find them. So here's our 2. This is the 2 that's sitting over here, which is pretty cool. It works out pretty well.